Find x rounded to one decimal place. We're given two right triangles where x is the hypotenuse of the second right triangle. To use trigonometry to find this x using this right triangle, we would need to know at least one of the remaining sides. We have none for this right triangle, but we can find this side using the first right triangle. And so this is the intermediate step. We would label this side z for now. We're not looking for z, we're looking for x, but from what we just argued, we would need to find z so that we can find x. Looking at this first triangle, the right triangle, we have the angle 60 degrees with the opposite side. And so we would use sine of 60 degrees equals the opposite side, which is 50 over the hypotenuse of the first right triangle. We deliberately use sine but not other trigonometric function because we have opposites known and hypotenuse unknown. SOHCAHTOA, sine is opposite over hypotenuse. From here, we can isolate z to obtain z equals 50 divided by sine of 60 degrees. Sine of 60 degrees is the square root of 3 over 2. So this is 100 divided by the square root of 3, or 100 root 3 over 3. We do not want to use decimal. We want to use the exact answers as possible. Now that we found z, we will go ahead and find x. Using the second right triangle, given the angle 65 degrees, z is the opposite to 65 degrees and x is the hypotenuse, opposite and hypotenuse again. So with the second right triangle, we will use the sine function again. Sine of 65 degrees this time is the opposite z over the hypotenuse x. But we found z. Z is 100 root 3 over 3. But before we plugged in z, we will go ahead and isolate x for now. X is z over sine of 65 degrees, where z is 100 root 3 over 3, and sine of 65 degrees is not an exact number because 65 degrees is not one of the special angles on the unit circle. Therefore, to obtain the result, we would need to use a calculator. Make sure our calculator is set in degrees mode because 65, the unit is degree. We should get 63.7 rounded to one decimal place.